Hi, welcome to my channel. This is Physics Guna. Today in our talk class, I am going to be talk about the polarization by reflection. So before entering into that, first we have to know about the reflection and polarization. When the light rays are incidenting on a smooth surface, they will get back into the media. That is called as a reflection. And polarization. The polarization is a process of the converting of unpolarized light into the polarized light is called as polarization. As we know that the light coming from the sun, the light coming from the lights, these are all unpolarized light. That means unpolarized light means in the light the particles are vibrating in all the directions. That means this polarization is explained as the nature of the light is transverse nature. For example, if the light is passing like this, okay, the vibrations of the particles are perpendicular to the propagation direction. Okay. Now in our today's class, we are going to be discuss about the polarization by reflection. That means by using this reflection concept, we have to produce the polarized light. Can we do? Yeah. So first of all, this polarization by reflection was introduced by Malus. Okay, he is a French scientist. In 1808, he was observed that okay, it is a transparent medium. It is a transparent medium, like either maybe the water or glass. And it is the first medium that is I am taking as a air whose refractive index I am taking as a N1. And it is I am taking as a glass medium that its refractive index is I am taking as a N2. It is a plane surface. For a plane surface, if you draw a perpendicular line, that one we are calling as a normal. Now, if we incident the unpolarized light, this is a unpolarized light. As we know that in unpolarized light, it has two vibrations. So that is vertical vibrations and also the horizontal vibrations. These vertical vibrations we are denoting with are double-ended arrows and also the dot representing as horizontal vibrations. Okay, so what is horizontal vibration and what is vertical vibrations in our previous class we have discussed. So this is actually I am naming as a P. Okay, and where it is meeting that interface is that point I am taking as a O. Okay, so here, my dear friends, in detail explanation I am giving. Please try to patient. Okay. So whenever the light rays are incidenting on a smooth surface, what will happen? Some of the light will be participate in a reflection, and some of the light will be changed from that medium to the another medium. It is a air medium. It is water medium. That means it is denser medium. It is denser medium. As we know that when the light rays are travel from the rarer medium to the denser medium, refraction takes place. Refraction takes place. The refracted ray is travels towards the normal, and the angle we are calling as angle of refraction. Okay, and this is the refracted ray. So what he was observed is, Malus observed that in the reflected beam, he was observed a partially plane polarized light. Partially plane polarized light. That means more number of one type of vibrations and also less number of another vibrations are there. Okay. After that, Brewster used that concept. Brewster used that concept, and also he has changed the angle of incidence. So what is this angle? The angle which are calling as the angle of incidence. According to the laws of reflection, the angle of incidence must be equals to the angle of reflection. That's why it is also called equal I. Okay. Now what he was done? So Brewster, okay, what he was changed is he was changed the angle of incidence. Whenever he was changed the angle of incidence, okay, what he was observed is, okay, the reflected beam is perfectly plane polarized. Perfectly plane polarized. That means in the reflected beam, these two are observed that, okay, the vibrations of the particles are confined to only one plane. Then that light we are calling as a polarized light. Okay, now it is angle of incidence and it is also equals to the angle of reflection is also equal. So according to the law of reflection, and this one we are calling as a O, and this one we can take as a Q, and this one we can take as a R, and this one we can take as a S, or otherwise we can take this one as a N dash. Okay, so once again, if the light is coming from the denser medium to the rarer medium, okay, that will away from the normal, away from the normal. Okay, we have to leave that one. First of all, we have to be discuss about that. And so that means at a particular angle of incidence, at a particular angle of incidence, the reflected beam is perfectly plane polarizing. That angle we are calling as angle of polarization. That angle we are calling as a angle of polarization. So angle of polarization means at which angle of incidence, the reflected beam is perfectly plane polarized. That angle is called as a angle of polarization. So, and that angle is also called as Brewster's angle. Okay, this one is also called as a Brewster's angle. So we may have taken IP or theta p, Brewster's angle. And the Brewster suggested one law for us, that is the Brewster's law we are calling as, what we are calling as a Brewster's law is the tangent of angle of polarization, which is equals to the refractive index of the material. That is called as a Brewster's law. And also he was explained one more, that is the reflected ray. This is a reflected ray. This is a reflected ray. And what is this? This is a refracted ray. This is refracted ray. That reflected ray and refracted ray both are right angle. Both are right angle. Based on small derivation, I would like to prove that one. So what we have to prove? Reflected ray and refracted ray are perpendicular, or right angles are perpendicular. This one we are going to be prove. Okay, regarding that one, what we have to take is, we have to take Snell's law. What is Snell's law? According to the Snell's law, the refractive index of the medium can be defined as it is the ratio of sine of angle of incidence to the sine of angle of refraction. That one we can call as a equation number 1. According to Brewster's law, what we know? According to Brewster's law, okay, the refractive index of the material is equals to the tangent of angle of incidence, or a polarized angle. That means this one can I write like sine I by cos I? Yes. So this equation I am calling as a equation 2. From equations 1 and 2, what we can write is, from equations 1 and 2, okay, sine I by sine R equals to sine I by cos I. Okay, If sine cancel, the equation can be written like this. How can we write? Okay. So that one we can write cos I equals to sine r. According to the trigonometry, what we know is sine of 90 minus theta or a I, which is equals to cos theta. So by using this trigonometric formula, we have to write this one. Sine of 90 minus I equals to sine r. Sine r. So that implies if both sides sine cancel, so that means 90 minus I equals to r. That implies I plus r equals to 90 degrees. This is so called equation number 3. Now, from the diagram, okay, this one you can take. So, angle NOQ, angle from diagram, angle NOQ plus QOR plus RO N dash or N dash OR equals to 180 degrees. How much? 180 degrees. Is it 180 degrees or not? Semicircle or 180 degrees. NOQ, the angle between that is I, plus QOR. We don't know. We want to calculate the angle between the reflected ray and refracted ray. And Q N dash OR, which is equals to the angle of refraction, that equals to 180 degrees. That implies angle QOR equals to 180 minus of I plus R. Okay, that equals to 180 minus I plus R. How much from equation 3? That is 90. Okay, how we got this? From equation 3. Okay, therefore angle QOR equals to 90 degrees. Therefore, reflected ray and refracted ray are perpendicular. Okay, this is the concept of polarization by reflection. If you have any doubts, please leave your comments in my comment box. So, thank you for your patience. Thank you.